We're going to be talking about polygons in Chapter 6. Today we're talking about the angles within polygons and the angles outside of polygons. So we're talking about the interior and exterior angles of a polygon. So just starting off here, we do have different names for our different polygons depending upon how many sides they have. Okay, so a polygon with 3 sides is just called a triangle. Okay, polygon with 3 sides is a triangle. A polygon with 4 sides is a quadrilateral. Okay, it's a quadrilateral. A polygon with 5 sides is a pentagon. A polygon with 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. Sorry. 12 sides is a dodecagon.
Okay, now they're just going to make up names.
No. Okay, and then if you have any more than that, you can just call it an n-gon. So depending upon how many sides there are, so say it says there's 27 sides. Okay, you would call it a 27-gon. That's fine. Okay. So you don't have to memorize what these are. It's just so that you have them in your notes somewhere. So if a problem asks you what is the interior angle sum of a heptagon, you know what a heptagon is. You can look back at this chart and say, okay, that has 7 sides.
Are we ever going to use n-gon?
N-gon? Yeah, I'll say something like, what is one interior angle of a 30-gon? 30-gon. So it has 30 sides.
Well, isn't
I have a question. Remember to use the
In what? Well, you have to, pass high school to do that. But like, alright, so next what I want to do is talk about diagonals within a polygon. So diagonal are segments that connect the non-consecutive vertices of a polygon. Okay, non-consecutive meaning you're not connecting to the angle next to it. You're connecting to angles that are across from it. So some examples here for 1 and 2. If I want to draw in all of the diagonals here, say I start at this angle in the corner, I can't draw in a diagonal to that next angle that's right next to this one. Okay, that's a consecutive angle. I would have to draw in my diagonal to the opposite side there. Okay, so it has to go through your polygon. Okay, there's one more diagonal that I can draw in. So if I go from here, I would have another diagonal over here. Okay, the other ones, if you were to try to draw those in, would connect along the side. So you can't have a diagonal that connects along the side right here. Okay, that's not a diagonal. Okay, I want you to try number 2. So you want to draw in all of the diagonals for that polygon. Okay, all of the diagonals from each angle. All of the diagonals from each angle.
Wait, so that bottom one, would you really connect the top two to them?
Yep.
It's not that anymore. It's,
I just we're good on it.
only that shit is.
Like that.
So with your diagonals, you do have to connect those to an angle. Okay, so it should go from one angle to another angle. Your diagonal should not connect to a side of your polygon. Okay, so for a couple of you, I saw it connect to a side. It has to go from an angle to an angle. Okay, so shh, coming back now, quiet. So if I look at this angle right here, okay, I can't connect to this angle because that's consecutive. It's next to it. I can, however, connect to the angle across from it. What about this angle? Is this a consecutive angle? It's not.
Ow.
This angle is a consecutive angle. Okay, this angle is right next to it. This angle is not. Okay, so that is also considered a diagonal.
Wait,
What?
Huh?
From here?
No, the other side, because like,
This one?
the other one.
This one?
Yeah.
You can. So if I go from this angle, this is a diagonal. And this is also a diagonal.
Okay, yeah, that's what it is. So you can't do that angle unless you draw the one that.
You're just looking for all of the diagonals from each angle. So not just from one. You go to all of the angles to find the
you
diagonals.
go from the bottom angle to where it intersects.
Yeah.
Oh, I did that right. I did.
There's another one. Shh, guys, I need you to be quiet. So I went from this angle. I had two diagonals. This angle, I have one here. This is also a diagonal, but I already had it drawn in. If I go from this bottom one right here, I could connect to this top angle. I can also connect to this top angle here. Okay? If I look at the other two angles that I didn't go from yet, I already have both of those diagonals in, so I don't need to redraw them. Okay, so as long as you can make a segment go through your polygon, it's considered a diagonal, as long as they connect to the angles. Okay, they have to connect to the angles. Questions? All right, then in 3 and 4, we're just going to draw in the diagonals from point A. Okay, so in number 3, from angle A, we're just drawing in those diagonals, so I can't, again, draw it up this way. I can draw it to that second one there. And I can draw it to this third one here. But I couldn't draw it to this fourth one over here because that's along the side. Okay, so angle to an angle, angle to an angle. Same thing in number 4, from point A. I can't connect to this angle over here because that's along the side. Moving to the next angle, that does go through the polygon. Third angle here, that's along the side, so I can't connect those. Okay, so that's how you draw in your diagonal from a given angle. So I did this because the next part talks about what the interior angle sum is using triangles. So when you draw all of the diagonals from one vertex of an n-gon, it separates the polygon into n minus 2 triangles. Okay, so I drew in the diagonals from one vertex here. Okay, I only had one diagonal. So your n value is the number of sides. So n is the number of sides. So if I look at number 4 here, that figure has 4 sides, right? So if I plug in 4 for n, I would have 4 minus 2. Okay, that is 2. So your diagonal splits that into 2 triangles. Do you see that? In number 4, split into 2 triangles. If I look at number 3, I have 5 sides, right? So I would plug in 5 for n. So I have 5 minus 2 is 3. So my diagonal should split it into 3 triangles. Okay, do you see those? Okay, so that's true for any sized polygon. Okay, you draw in all of the diagonals from one angle. It splits it into n minus 2 triangles. Okay, we use that to help us find the interior angle sum, which is what we're going to go over next. So the sum of the measures of interior angles of a polygon can be found by adding the measures of the interior angles of those n minus 2 triangles. What is a triangle's interior angle sum? What do they all 3 of your angles have to add to? 180, right? So that means here, all 3 of these angles would have to add to 180, right? All 3 of these angles would have to add to 180. I would just have to add those together to get that interior angle sum. Same thing here. This would be a 180. Those 3 would add to 180, and those 3 would add to 180. So I just multiply by 3 and 180 to get that interior angle sum. So our formula for finding interior angle sum is n minus 2 times 180. Okay, so you're taking those triangles, that's the n minus 2 part, multiplying by that triangle interior angle sum, which is 180, to get your polygon's total interior angles. Okay, so we're going to do an example using that formula. Okay, so we have a convex polygon that has 13 sides. Okay, so since it has 13 sides, n is 13. Okay, n is your number of sides. We want to find the sum of the measures of the interior angles. Okay, to find our interior angle sum, we use n minus 2 times 180. And we know how many sides we have. It's 13. So we have 13 minus 2 times 180. So that is 11 times 180, which is 1,980 degrees. So if you have a 13-sided figure and you want to add up all of the angles in that figure, it should be 1,980. Okay, that would be the sum of those interior angles. Questions on example 1? Okay, then if you go to the back, example 2, this time you're given a polygon. Okay, we want to solve for x. Okay, I can't add all of these to be 180, it's not a triangle. I have to first find the interior angle sum of that polygon. You see that? Okay, so I first have to find the interior angle sum, which is what we just did on the front. Okay, So I need to know how many sides are in this figure. Okay, so I have 1, 2, 3, 4, 5 sides. So using that formula from the front, I would have 5 minus 2, since n is 5, right, times 180, which is just 3 times 180. That's 540 degrees. So that means all of the angles in this figure have to add to be 540. Okay, so in order to solve for x, all I would have to do then is add all 5 of those angles together and set it equal to 540 degrees. Okay, so I have 7x plus 4x plus 5 is angle D. Angle C is 5x minus 5. Angle B is 6x plus 10. And angle A is 4x plus 10. Okay, all of those added together have to be your interior angle sum of 540. Okay, so with this, first step is to find that interior angle sum and then add them all up to be that sum. Okay, so combine like terms on the left. I have a 7x, a 4x, a 5x, a 6x, and a 4x. Okay, that is 26x. Combine your constants here. I have a 5 minus a 5. Okay, those just cancel. Then I have a 10 plus a 10. That's just 20. And that's still equal to 540. Subtract 20. So we have 26x is equal to 520. Divide by 26. To get x is equal to 20. Okay, questions on how I started example 2? Okay, so you need to find that interior angle sum first so you know what they all add up to be. Okay, it's not 180. It's only 180 for a triangle. No questions? You're good? All right. So next I want to talk about a regular polygon. Okay, so a regular polygon is a polygon with all sides congruent and all angles congruent. Okay, so all your sides are going to be the same length and all of your angles are going to be the same measure. Okay, all sides the same, all angles the same. So with that, if we have a regular polygon, we can find out what one interior angle is. Okay, so the measure of one interior angle of a regular polygon is equal to n minus 2 times 180 divided by n. Okay, so this is your formula to find one interior angle. On the front, that was the sum of the interior angles. This is one interior angle. Okay, where again, n is still equal to your number of sides. Okay, so n is still your number of sides. So we're going to use this to do example 3. Okay, now example 3 can be done 2 different ways. So I'm going to split this. Okay, you can do this example 2 different ways, and I want to show you both. All right, so example 3 says the measure of an interior angle of a regular polygon is 120. We want to find the number of sides. That means I'm finding what n is. Okay, you are given the interior angle. That means for our first way here, what we can do is take our formula that I highlighted and set it equal to 120. Okay, 120 is not n. Okay, 120 is not your number of sides. You are trying to find your number of sides. So you have to solve for n. So I would take my formula, n minus 2 times 180, divide by n. That formula gives you your interior angle. So I would set it equal to that interior angle. From here, I need to solve for n. So the first step in doing that is getting that n out of the denominator. Okay, to get n out of the denominator, you're going to multiply both sides. That way it cancels on the left. So we have n minus 2 times 180 is equal to 120n. Next, since I have these parentheses and a number on the outside, I'm going to distribute 180 to both n and this minus 2 here. Okay, so we have 180n, so multiplying those. Then negative 2 times 180 will be minus 360, and that's still equal to 120n. So now I can continue solving for n from here. So subtract 180n. When I do that, I end up with negative 360 on the left and negative 60n on the right. Okay, then to finish getting n by itself, we would just divide both sides by negative 60. And I have a negative divided by a negative, so it is positive. To get n is equal to 6. Okay, so you have 6 sides to that polygon. Questions? Okay, before I do the second way, I do have to go over what the next section says, and then I'll come back up. So there is a simple relationship among exterior angles of a convex polygon. Okay, you have an exterior angle sum theorem just like you had an interior angle sum theorem. Except with exterior angle sums, it is always going to be equal to 360. There is no formula. Your exterior sum is always 360, no matter what size polygon you have. Okay, exterior angle sum is always 360. Now, with your exterior and interior angles, okay, there's a relationship among those as well. Your exterior and interior make a straight line. Okay. Okay, so if that one's your interior angle, this one is your exterior. They make a straight line, meaning if I were to add them together, what would they have to equal? 180. Okay, so if you take your interior angle plus your exterior angle, it should equal 180. Okay, if you add those two together, it is equal to 180. So continuing down here, example 4, we want to find the sum of the measures of the exterior angles of a convex 27-gon. What is the sum of your exterior angles? 360. Again, no formula for finding sum of exterior angles. It is 360 degrees no matter what size polygon you have. Okay, example 5, we're using exterior angles as well. So we want to find the measure of each exterior angle this time of a regular hexagon. Okay, so not the sum of the exteriors, we want to find each one. Okay, so that means I'm just finding one of these angles on the outside right here. Well, how many exterior angles total do I have? If this is a hexagon? 6. Okay, you have 6 sides, so there are 6 exterior angles. So if I know what the exterior sum is, and all of those exterior angles are going to be the same, what could I do with that sum? If all 6 of your exteriors are the same and your sum is 360. You can take your exterior sum and divide by how many angles you have. Okay, that's your exterior sum. Divide by your number of sides. Okay, so each exterior angle will be 60 degrees. Questions? All right, I'm going to go back up here. Example 3, your second way to do this. So, like I said up here, one interior and one exterior have to equal 180, right? Okay, they make a straight line. In this one, I'm given one interior angle is 120 degrees. So I can find what one exterior angle is. Okay, so I can take 180, subtract 120. Okay, 180 is your exterior and interior together. Right, because they make a straight line. If I subtract 120, which is your interior angle, that will give you one exterior angle. Okay, and we just learned that your exterior angle sum is 360. So if I know what each of my exterior angles, what each measure is, I can take that exterior angle sum of 360 and divide by your exterior angle. So that's your sum. This is your exterior angle. Okay, and that will give you your number of sides, which is 6. Okay, so one interior and one exterior together create a straight line, so they equal 180. So you can always find one exterior angle, and since the sum of your exteriors is always 360, you can just divide by that one exterior to get your number of sides.